Hello students, today we are going to start the topic that is limitations and exceptions of octet rule. So according to octet rule, every element react with other elements only for the completion of their octets or duplets. But there are some limitations of this rule. So these are the exceptions and limitations. So first limitation is the electron deficient molecules. So there are some molecules in which the central atom is surrounded by less than 8 electrons, that is their octet is incomplete. Okay, for example, like BeCl2, Bf3, AlCl3, LiCl, BeH2. Now we have to understand this example like Be. Be is beryllium and it has the atomic number hydrogen, helium, lithium, beryllium, that is 4, correct? And it needs 2 electron, it needs 4 electron for the completion of their octet. But here you can see this is this form only, it forms only BeCl2, while for the completion of its octet it required 4 electron. Okay, but it form only BeCl2. That means only 1 electron it is getting from the Cl. So its electron, its octet is still is not complete. So this is the exception or limitation. So these are the elements which are electron deficient elements like beryllium, boron, aluminium, lithium, beryllium. So these are the electron deficient elements. While they are reacting with other elements like F, Cl and H, but they are, because they are deficient in electron, so their octet will not complete. And the second reason is also that they don't have the vacant d orbitals, so that's why they do not accept the more electrons from the other element. Now the second limitation is the odd electron molecule. So molecules like NO, NO2, oxygen, that is O2, etc. are examples of such molecules in which bonded atoms have odd number of electrons, like NO. You can see here N has the atomic number 7, and oxygen has the atomic number 8. Okay, so when you add this 7 and 8, this will be 15, and 15 is the odd number. Okay, that will not be the even number. Now next limitation is, you can here you can see the examples of like nitric oxide, oxygen molecule, nitrogen dioxide. You can count the electrons also here. Like you can see here that the oxygen has the 8 electrons, and here oxygen also has the 8 electrons by the bonding of this nitrogen. But here you can see this one electron, due to the presence of this odd 1 electron, the octet rule is not, or octet rule is violated. So species with one unpaired electron are called free radicals, and these are paramagnetic, and most of them are generally unstable. So due to the presence of a single or odd electron, they will call as the free radicals, and they are very reactive and paramagnetic in nature. Next limitation is the electron rich molecules. So just like the electron deficient molecule, electron rich molecules also exist. That means that due to the availability of the d orbitals, they can expand their covalency and can accommodate more than 8 valence electrons around the central atom. So this is referred as an expanded octet. That means they are the elements, they are the molecules which can complete their octet, but they accept more electrons than the octet. That means 8 plus 4 or 8 plus 6, just like that. So here you can see the PF5, this is the example. So it will complete its 10 electrons around P, not octet. Okay, so it violates the octet rule, just like that. Another example is SF6, so 12 electrons around S atom. This also violates the octet rule. Another example is H2SO4, so you can see there are 12 electrons around the S atom. That means in these 3 examples are showing here that these are not completed the octet rule, even they accept more electrons than the octet. So these are the diagrams of these molecules. Here you can count the valence electrons surrounding the central atom. This is the central atom, this sulfur is central atom. So you can count the electrons from here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 electrons in the surrounding of S atom. Here also 12 electrons, and here 10 electrons around the P. Compounds having expanded octet are also termed as the hypervalent compounds. These type of compounds are called the hypervalent compounds. Now the some other drawbacks of this theory are as follows. So like next is, octet rule is based on the inertness of noble gases, but some noble gases like xenon, krypton form several compounds which oxygen and fluorine, like XeF2, XeF4, XeF6. So it is just like this is Xe. So it has 8 electrons in its valence shell, correct? So you can draw it like this. So already its octet has been completed, but it can react with the another element like F. Okay, and when it reacts with the fluorine, it will complete 10 electrons around it. Okay, just like that, XeF4, XeF6, XeOF4, XeO2F2, and KrF2. So these are the examples of noble gases which can complete their octets, and but after that they will accept or share the electrons from the other elements to make bond. So it does not tell anything about the shapes of the molecules and their relative stabilities. Next is it fails to explain the paramagnetic behavior of oxygen. Okay, so these are the limitations of octet rule. Now next is the covalent character in ionic bonding, or we can say the Fajans rule. So although in the ionic compound the bond is considered to be 100% ionic, okay, in ionic compound we say that the bond is 100% ionic, but actually it has some covalent character. It's just as covalent bond has some ionic character, ionic bonds have some covalent character. That means ionic bond has some covalent character and covalent bond has some ionic character. Okay, now when a cation approaches an anion, the electron cloud of the anion is attracted towards the cation and hence get distorted. That means it is saying that this is anion, okay, and electron cloud, that means this is like this. So electron cloud is present around this anion, and this cloud is attracted by the cation. Okay, so the structure of the anion, or so structure of the anion will distort. Okay, and this effect is called the polarization. What is the polarization? For example, this is a molecule of HCl. Okay, but we know that Cl is a negative and H is positive. So when H positive is attracted towards the Cl negative, there will be polarization occur between these two elements. So due to polarity, their structure will be like Cl negative. Okay, so the power of the cation to polarize the anion is called its polarizing power. What is it's saying that the power of the cation to polarize the anion is called the polarizing power. This important line. Okay, so and the tendency of the anion to get polarized is called the polarizability. This line is very important. This the tendency of anion to get polarized is called the polarizability. Greater the polarization produced, more is the neutralization of the charges. Polarization will be more. If the polarization will be more, neutralization of the charges will be more. Neutralization of the charges will be more, and hence the ionic character decreases. And because of the neutralization, ionic character will decreases. Okay, these are three relations. Polarizability increases, neutralization increases, and ionic character will be decreases. And whenever the ionic character decreases, covalent character increases. Ionic character will decrease. When ionic character will decrease, covalent will be increase. Hence, we are getting a conclusion that the ionic character is inversely proportional to the covalent character. Now, the properties like melting point, heat of sublimation, solubility in water, or non-solvents change accordingly. The polarizing power and hence the formation of covalent bond is favored by the following factors. So, first one is the small size of cation. So, the small cation, because of their high electron density, tend to distort or polarize the electron cloud of the anion to greater extent. Hence, the compounds containing small cations will have more covalent. That means the molecule which have the less charges are more covalent. Correct? For example, like LiCl. Okay, so LiCl is a covalent compound because it contains only one positive charge. And what is the effect of size here? Because lithium has a smaller size in comparison of Na and K. So due to the smaller size of lithium, it has the covalent character in comparison of Na and K positive, Na positive and K positive. Next is the large size of the anion. So larger the anion, greater is the polarizability. So in case of larger anion, the hold on the electron cloud by the nucleus decreases. So here you can see the anion will be larger. If anion will be larger, like I has a greater size in comparison of the Br and Cl. Correct? And it already said that the larger the size of an ion, greater is its polarizability. Okay, so you can see the size of the iodine is greater in comparison of Br and Cl. Hence the polarizability of I compound will be great. Now, because of this fact, the covalent character of lithium halides is in the order of, so the lithium iodide will have the more covalent nature in comparison of the LiBr, LiCl and LiF. So you can see the order of the covalent character. Li I have more covalent nature. So Li I have the more covalent nature, and we know that the covalent bonds are weaker or lesser melting point or boiling point in comparison with the ionic compounds. So you can see the LiF is a more ionic character, hence its boiling point or melting points will be greater than the covalent compound. Now high charge on the cation or anion. So higher the charge on the cation, greater is its polarizable power. Higher the charge on the cation. Okay, so you can see the examples like Al plus 3, Mg2 plus, and Na plus. So the charge on the Al3 plus is greater in comparison of the Na positive. So the polarizing power of Al3 plus is greater than the Na positive. Okay. Now electronic configuration of the cations. So in case of two cations having the same size and charges, same size and same charges, the one with pseudo noble gas configuration with 18 electrons in the outermost shell has polarizing power as compared to the greater polarizing power as compared to the other with noble gas configuration. Okay, so the cations which have the configuration just like the noble gas configuration, so they have the more polarizing power. Now the effect of polarization of ion on the properties of compound. So what are the effects of polarization on the ions? So the first is as polarization or covalent character increases, melting point of ionic compounds decreases. Okay, polarization increase. When polarization will increase, covalent character also increase, and whenever covalent character increases, ionic character will be decreases. Hence, the melting point will be also decreases. So you can see here the AlBr3 has a more covalent in nature in comparison of LiF. Hence, the melting point of AlBr3 is very less in comparison of LiF. Now, as polarization increase, so polarization increase, when polarization increase, the covalent nature also increase, and ionic will be decrease. Correct. And when ionic, that means covalent character when increases, the solubility of ionic compound decreases. Okay. When covalent character will increase, the solubility will decrease. Now, next is more will be the polarization, lesser will be the thermal stability. More will be the polarization. So you can see here the more will be the polarization, that means the covalent character will increase. So you can see here the MgCO3 has a more polarizability and has a more covalent character. That's why the thermal stability of the magnesium carbonate is very less. Sorry, greater, maximum. Okay, thermal stability compounds have the maximum temperature. So what is the conclusion now? That more will be the polarization, more will be the covalent character, and more will be the thermal stability. You can write it in short like more polarization, okay, more polarization, more covalent character, and more thermal stability. Okay, this is directly proportional relation. Now last one is the bromide, iodide, sulfide of metal ion having pseudo inert gas configuration are colored due to presence of polarization. So like bromide, iodide, sulfide, they need only one electron for the completion of their octets or for attaining the inert gas configuration. That's why they have we are called that pseudo inert gas configuration. Okay, they have the pseudo inert gas configuration, and due to this reason they are colored. Okay, because they have the more polarizability. So you can see the AgBr is yellow, AgS is black, PVS is black, AgI2 is red, AgI is dark yellow, AgS black, and sp2, S3 orange.